Okay, so today's daily question is, let me check if I'm recording everything right. Should be fine. Let's make it louder. Okay. So today's problem is today's daily is final array state after key multiplication operations. So I solved it like this August. I guess it was on the contest. So I'll try to solve it again. Let me quickly read the problem statement. Okay, this is already a solution. So I wanna just have priority queue here with integer indexes q equals new priority queue. And then in that priority queue I wanna integer index and then the value itself. And this in this priority queue I'm gonna p1, p2. I'm gonna sort by the values return integer dot compare, and then int p1 1. So I'm gonna store the index on the index 1. The all positive, yes. So I'll do this for int I equal 0 less than nums plus, and then I'll do pq.offer new integer and then the value itself nums I and then the index I, and then I'll do this while key operations, while k greater than 0 and then k minus minus, and then return nums, and then I wanna do pq dot poll, and this should return the pair, and then nums pair 0 equals nums equals pair 1 multiplied by what? By x, by multiplier, okay? Multiplier, and then pq, let's say, gonna have int pair 1 equals p1 not have a multiplier, and then nums p0 equals p1, then pq over p. That should be it. Okay. No. That appears first. Okay, I missed that one. If they're equal, then return integer compare indexes. Okay, let's check what we have here. Key operations. We know that k is less than 10. So we need to just multiply the smallest one. So here, go from 0 to k. Why we want multiplied by the itself? What is I? Okay, we find the minimum. Okay, for every key we find the minimum and then multiply it by a multiplier, so it can be the same number over and over again. Okay, just simple. Just simple limited. Yeah, I actually can priority queue. I can reduce the priority queue. So I need to keep k minimums. So I need to have max heap. And if I'm gonna have max heap, there might be situations when the minimum, like say we have 100, 100, 100. And in this case, we always have to, and let's say multiplier is like 2. And in this case, I need to access only 1 instead of 100 if let's say k is equal to 2 or 3. I always accessing 1, and it means that but at max heap I need to create min heap from that max heap. That will save some time, but not much. Let's check the description editorial. Okay. Heap optimized offer. Yeah, so heap can be. So I was thinking about reducing the size of this heap instead of saving n elements, saving just k elements in this heap, so we can use at maximum k elements, but maybe even less. But the problem is that I need to first create max heap to have a to always exclude the maximum value if I observe one, and then I need to put them back into a min heap here so that I can always take a minimum and then multiply it by something by multiplier and then put it back to the min heap. So it's a little bit if it's really worth it in this situation. Yeah, the same is here. Okay, that's it.